Okay, last three students, I have completed the chapter regarding geometry and shapes and patterns, all these things. Now, geometry and patterns completed. Now I'm going to discuss with you Matheletics A and Matheletics B. It is a very necessary thing to discuss the exercises. And these A and B, these two are concept कैलकुलेशन स्किल्स डेवलपमेंट के लिए बहुत अच्छे होते हैं एंड these workouts and these mathematics are also helping you to develop higher skills of thinking. So let me start with Matheletics A. Matheletics A, open at page number 62. The number 1. What can you see? There are some clues given. And you will have to name the shapes. A. Name the shapes described. A. It has two flat faces. Two flat faces. One carved face. Two carved edges. But no corners. What is this? This is nothing but a what? I will not name it. Come on, tell me. What is said? It has two flat faces. This is a flat face. And this is another flat face. These are two flat faces. One carved face. One carved face. This is a carved face. One. Two carved edges. This is one edge and this is the other edge, but no corners. So what is it? Now you all know this is a cylinder. I'm not going to draw every picture. Number B. Three straight sides. Three straight sides. No curved sides. Three corners. My goodness, it is a plain face. Three sides. One side, the other side, and the third one. Three sides, no curved side, it has no curved sides, well, and three corners. Here it is, one corner, the other corner, and the third corner. So it's nothing but a triangle. Let's go to C. One curved face, well, it has one curved face, no flat faces. It has only one curved face, but no flat faces, edges, or corners. It neither has flat face nor edge or corner. So what is it? What type of thing is it? One curved face. Face, not side. If you are told that one curved side, then it would be a circle. But you are saying what? It has one curved face. What is it? It's a sphere. Now let's go to D. Now, 6 flat faces. My God, 6. 12 straight edges, not sides. 12 straight edges. 8 corners. Very good. Now the answer is not 1. There are 2 answers. You all know a cube. You all know a cube has all these properties. It has faces, flat faces. How many? 6. Yes. It has edges. How many? 12. It has corners. How many? 8. So one of your answers will be a cube. As because it has all these 3 properties. 6 faces, 1, 2, 3, 4, 5, and the lower one, 6. 12 edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So one of your answer will be Q. Now what will be the next answer? All these properties are present in another shape, another solid shape. What is it? Let me draw it. It is nothing but a cuboid. It is nothing but a cuboid. It's a cuboid. It has all these 3 properties. 6 faces, 12 edges, and 8 corners. So the next answer will be cuboid. Clear? Fine. Let me clear the board. Okay. Number 2. Name these geometrical concepts. What are geometrical concepts? The true things of geometry are called geometrical concepts, on which you build your diagrams, on which you build something more. The concepts, as you have learned, in case of lines, there is no beginning point, neither has it has any end point. So it is marked with arrows on both the ends. In case of a ray, there is obviously a beginning point, but it does not have an end point. So the other point of that line is marked with an arrow. In case of a line segment, it does have a beginning and an end. So there is no arrow at both the ends. These are the concepts. These are the geometrical concepts on which you are asked to answer A and B. A, it has a position, surely it has a position, but no length, no breadth or thickness. It does not have length, it does not have breadth, it does not have thickness, but it certainly has a position. What is it? Only a point has no length, breadth, or thickness, but it surely has a position. More clearly, a point shows a position, denotes a position. Let me go to B. It has a beginning, fine, it has a beginning, but no end. It has a beginning but no end. Well, it has a beginning. It certainly has a beginning here, but it has no end as there is an arrow. So what is it? A ray. It has a beginning but no end. So you all have answered both the questions of A. Now in number 3, look at number 3. You are asked to draw a line segment of 7 centimeter long. It's very easy. Take your scale and draw it on your book. A line segment, not a line, neither a ray, a line segment of 7 centimeter long. Start from 0. You must start from what? 0 centimeter, and stop at where? Where should you stop? You should stop at 7 centimeter. Okay, and you name the ray, name the line segment A, B. Like this, you will have to draw. So 3 is complete. Number 4, there is a picture of a ray or an arrow. You are asked to measure the length of the arrow. Take a scale and measure it. 5. Go to number 5. 4, measure and write with unit. You must write the unit, centimeter or inches, whatever. Number 5. Here are the patterns. I have told you the last day, I might have told you in this class or any other class anyway, the process of rotation, clockwise and anti-clockwise. As you have seen, the hands of a clock moves in the clockwise direction, that means in the right side, towards the right side. And if, just imagine, those hands move in the opposite direction, towards the left, we call it anti-clockwise direction. Let me show you by a diagram. If anything moves in this way, that means towards left to right, in a cyclic path, obviously, it is called clockwise movement. What is it called? Clockwise. It is very important in case of geometry. And if any line moves opposite direction, in the opposite direction, that means towards the left, it is called anti-clockwise direction. What is it called? Anti-clockwise direction. So look at the picture. 5A. What's given there? There is a big square, yellow color, and inside the big yellow colored square, there is a green colored square in one corner of it. Small green colored square in one corner of it. Look at the picture. The first one, the first square has the green small square inside at the left upper corner. Left upper corner. Let me draw it out and show you. You must be very clear about these diagrams. Let me draw it, a square. So, this is the square in front of you. This part is yellow color and this part is green. Now, if this small square moves inside the larger square in clockwise direction, that means from left to right, then where will be the square in the next diagram? In the first diagram, that is number 1, it is here. And if this green square moves towards the right in the clockwise direction, then the next square will be where? It will be here. Isn't it so? It has moved in the rightward direction, towards right. ऐसी तरह move कर रहा है. It is moving in this pattern. Now, after this, where will be the next square, number 3 square? I am drawing all the 4 diagrams needed for you in this same picture. The other square will be, the next square, the number 3 square will be here. So it is moving in the clockwise direction. Number 3 is here. Look at the number 3 picture in your book. Look at the number 2 picture. As I have drawn, it's moving in the same pattern. Now, this square is moving even in the clockwise direction again. So where will be the fourth square, the blank part? Which one is needed? You are asked to draw. It will be here. So you have got the picture. You will have to draw a big square and the small square at the left lower corner of the square. Now it is clear. Let's go to 5B. There is a big circle, red. After that, there is a small yellow circle. And after that, there is a blue triangle. This is the pattern. So what is there before the yellow triangle? A big red square. So in the blank space, you will have to draw a big red circle. Big red circle. Why? Because it is followed by a small yellow circle. That's given in your book. Very easy. Now let me erase this page. Okay, it's clear now. Let's go to number 6. The end of Matheletics A. Here are four pictures given, 4 shapes given rather. The first one is a triangle. The next one is a circle. The third one is a square. And the fourth one is a hexagon. This hexagon is a shape which has 6 sides. It will take some time for me to, it will take some time for me to draw. Just wait a minute. Well, this is more or less the shape of a hexagon. Now, what is asked here? Put a cross on the shape that does not tile. I have discussed tiling in the previous video. Tiling is a pattern which is made without leaving any other space in between 2 shapes. That means, in case of this triangle, look at the picture I'm drawing. You can draw these things. It will make a tile. Is there any space left? No. All the space is filled up. You can draw it on your paper. The whole paper will be covered up by triangles and there will be no extra space left. In case of the square also, You can draw another square just after it. You can draw even a square down to it, beneath it, whatever you want. The whole paper will be covered without leaving a single space. In case of this hexagon also, you can draw multiple shapes without leaving any space in between. You can do it throughout this whole paper. There is no problem drawing it. But now look at me. Look at not me on the board. Here is a circle. If you draw another circle close to it, fine, no problem. But if you draw another circle here, if you draw another circle here, if you draw another circle there, what are you noticing? You are noticing this is a circle, this is a circle, excuse me, this is a circle, but notice this space. A little bit of space is left in between. Isn't so? Isn't it so? So, the answer will be the circle. You will have to put a cross on the circle. This figure, the circle, can't be used for tiling. In case of tiling, there is no space left. Those who have marble floors with square marbles, look at your floor. You see, there is no space left in between the two sheets of marble, of stones. You cannot make a full tiled floor with round shaped marble stones because there will be some space left in between them. Got it? Fine. So Matheletics A is completed. Let me go to Matheletics B. Let me create this board. Okay, Matheletics B. Here it is. MCQs, multiple choice questions. Number 1. Which plane figure will you draw on a sheet of paper to show an egg? It's very easy. An egg is oval in shape. Number 2, I'm going fast. Every face of a cube has how many faces? 6 faces. All 6 faces are squares. So every face of a cube is a square. Number 3, which solid shape has 2 plane faces and 1 curved face? 2 plane faces and 1 curved face of a solid. It is certainly a cylinder. The upper and the lower part has flat faces and in between them lies a curved face. Number 4, you have a cuboid. What is cuboid? The shape of your pencil box, the shape of a brick. Which of these can you measure using a scale? You can measure its length, you can measure its breadth, even you can measure its thickness or height. Thickness is also called height. So all of these, option number D, All of these we will be able to measure. Have you understood it? If not, I am giving you a diagram. This is a cuboid. Fine. Now take a scale. Take a scale. This is the length of the cuboid. The longer hand, the longer side of each face is the length. The shorter side, you can measure it here, even you can measure it there, wherever you want to. This is the shorter side. It is called the breadth. And the height, this one, the height, you can also measure it with the scale. So, this is the length. This is the breadth. This part. And height. You can measure all these three, what can it be said, dimensions. All these three dimensions with the help of a scale. This is height. Fine. Let's go to number 5 quickly. How many lines can you draw passing through both points P and Q? 2 points are given. One point is here and the other point is here. Let me name these 2 points. It is P and this is Q. These two are not lines, these two are points, remember. So how many lines can you draw from these 2 points? The line will cover these 2 points. Passing through, you can draw only a single line passing through these 2 points. How many lines can you draw passing through these 2 points? One and only one. Only one. Clear? Let's go to 6. How many line segments can you draw passing through a point X? Suppose you take a point. I've already told you that drawing a point is very, very tough. Even I'm trying it. Still I'm trying it. Suppose this is your point. And let me give it a name. It is named as X. Fine. So how many lines can you draw? How many lines can you draw through this point? Let me draw. Like this, you can draw numerous, many, uncountable. You can draw many, uncountable. You cannot count. Many uncountable number of lines can be drawn through a point, a single point. But through 2 points, you can draw only one line. Let's go to number 7. I think you are all understanding. Okay. How many line segments passing through any 2 points at a time? You can draw 2 points A, B, C, D, try it out. So let me draw 4 points. A, B point, C point, and D point. Now what's the question? How many line segments passing through any 2 points? Any 2 points. You can take, let me use the spotlight. Any 2 points means point A and point C, maybe point A and point D, maybe point B and point D, maybe B and point C, whatever. Any 2 points. How many line segments passing through any 2 points at a time can you draw through points A, B, C, D? Through any 2 points at a time, you can draw only one line. If you take A and D, fine. How many lines have you drawn through any 2 points? One at a time. You can draw from B to C. You can draw from A to C. You can draw from A to B. You can draw from B to D. You can draw from D to C, wherever you want to. But if you draw a line with 2 points, you can draw only one line at a time. So the answer will be only one. Fine. Let me go to the next page quickly. What is this? Okay. The next page. Here you see making models from nets. Here are many things given. Suppose these are the pictures of nets. Suppose there is a box made out of paper box or cardboard box. If you cut open the box, you will see these type of pictures. Look at the first picture A. A small triangle inside a big triangle. Actually, it was a pyramid-like structure. Look at A, triangular pyramid. Look at B point. Actually, it is a triangular prism with two triangular faces on the two ends, at the two ends, and three rectangular faces. This is a triangular prism, and if you cut open it, it will look like that, the upper one. Now look at C, it's a cube. Now if you cut open a cube, the paper will be like that, the upper part, number C. So by looking at these pictures, you will have to fill up the table given below. First of all, A, triangular prism, triangular prism. How many faces? 4 faces given. 4 faces, fine. Triangular prism has 4 faces. How many edges are there? How many edges are there? In case of a triangular prism, let me draw it. So it is a triangular prism. Okay. This is a triangular prism. My drawing is not perfect. Okay. This is a triangular prism. How many faces are there? Here it is said that it has 4 faces, but no. I think they may be wrong. Let me show you. This is a face, a triangular face. This is another face, a triangular face. This side is a face, and that very side and behind this face is another face. So 1, 2, 3, 4. And what about this lower one? What about this lower one? What about this lower one? So 5 faces. Fine, 5 faces. How many edges are there? Look at the picture, triangular prism. How many straight lines can you see? As many straight lines you can see, there are that many edges. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 edges. How many corners can you see? See how many corners? 1, 2, 3, 4, 5, 6. 6 corners. It is clear for a triangular prism. Now if you go to B. Oh, I'm sorry. In case of a triangular prism, the next one, B. Consider it B. Consider it B. Okay, fine, no problem. This is the triangular prism. Now consider A as, this is not A but B. Okay. Now consider A. It is a triangular pyramid. A triangular pyramid. The picture is given there. Let me draw it here. Okay. This is a triangular pyramid. So in case of this triangular pyramid, how many faces are there? There are 3 triangles standing. This is 1, this is number 2, and this is number 3. And 1 triangle at the bottom. So there are in total 4 faces. How many edges? As many straight lines as you can see. The lowermost face or the bottom face consists of 3 lines and 4, 5, 6. So 6 edges. And how many corners? Certainly 1, 2, 3, and 4. 4 corners are there. Clear? This 2 figure is different, so I have discussed. And in case of number C, there is nothing special in it. In case of a cube, you know how many faces are there of a cube? 6 faces. How many edges? 8 edges. I'm sorry, 12 edges. And how many corners are there? There are 4 corners. 4 on each face, there are 8 corners. Okay? So this is the end of your chapter. Go through these once again. Do these in your copy as many times as you want. Practice it. We will meet again in the next video. Bye-bye.